Alright, so looking at number 7. So number 7 is a little bit different here. We don't need a calculator for this one. We're not doing any math. We're not calculating anything. We're just kind of looking at an equation and then trying to figure out what's happening. So it says the equation y equals 100,000.95x models the population of a city over time. Is the city growing or declining? How do you know, and at what rate? Alright, so let's take the equation they give us here. We know that the first number represents A, right? The initial amount. So I know that we're saying it's a city that has 100,000 people in it. So this is our initial amount. And then we know that the number that's inside the parentheses represents how it's changing. So this is our rate. Now, what we have to figure out is that does 0.95 represent a rate that is growing or decaying? And so I think the thing that you're asking yourself is, well, is it 1 plus something that would give me 0.95? Or is it 1 minus something that would give me 0.95? And then the answer to that is that, well, it would have to be, because this number is less than 1, it would have to be a decay situation, right? So we'd have to be looking at this right here. So we know that that's the decay situation, and then we'd say, well, okay, well, what 1 minus what would have given me, maybe we'll kind of write this. So what we're saying is that, so 100,000, here's your initial amount. And then we're saying 1 minus what? Alright, let's put 1 minus what would give me, we're saying to the x, right? So it's kind of like working the problems backwards in a way. Would give me 0.95. So instead of going kind of from here to here, we're kind of going backwards. We're saying, well, 1 minus what would have given me 0.95? Well, 1 minus what would have given you 95 cents? Well, that would have to be that R is equal to 0.05, which would be 5%. Right? So what we could say is that we know that the city, the population, so let's kind of put all this together, the population is decreasing population is decreasing by 5%, because, and what we could say here is because the decay, in this case it was decay, right? Because that number, right, because the rate of change was less than 1, right? Because the rate of change or we could say the decay factor is less than 1. And we've already said that, right? Because if you went back, go back to that previous problem, we were talking about the fact that the truck was decreasing in value, so that's why this number ended up being less than 1. So again, if we know that this number is less than 1, then we know we're talking about something that is decreasing. Now, just for fun, let me kind of make something up, just so we make sure that you know how to kind of maybe answer the next question. Is that what if I had, and I'm just making something up here. Let's say I had y equals 150,000 times 1.05. Right? Let's say we had an equation that looked like that. Well, that would have to be, since that's greater than 1, that would have to be that the population is increasing, right? So the population would be increasing by, and then, what would you have added to get that? Well, 5.05 or 5%. So that's the difference, is that if it's less than 1, then we're talking about something that's decaying, getting smaller. Greater than 1, we're talking about something that's growing, getting bigger. All right, so go ahead and stop now and try number 7 on the right side.